This conference will now be recorded.
So hope you guys are able to see the screen. Do let me know in case if any one of you is not able to see. Okay, so in the previous session, we discussed about the non-functional requirements gathering, and also we discussed about few interview questions and how the data will be captured if client doesn't know anything about performance testing and all those questions. So far, we covered some important concepts. Like if you see the whole week, um, sorry, if you see the whole week, say we covered like what is performance testing, types of performance testing, and we also covered about some topics like the importance of software architecture, entire architecture, protocol, failover testing, and all those things. So in today's session, we will discuss about we'll have some discussion about workload modeling. See, actually, the implementation of this workload modeling practically will be done after scripting sessions when we actually create a scenario and run the test. Okay, but I want you to have some initial understanding of workload modeling because the terms like transactions, think time, pacing. So we might use these terms probably frequently in the entire course. So that's the reason I want you to have some initial understanding of what is workload modeling. So in general, um, what is the requirement? I mean, what kind of input do we get from client for the performance test in general? In general, what kind of input do we get from performance tests? For example, uh, so let's take any. It's a banking application. Let's take it is a banking application. Now, what are the critical scenarios for banking application? Last time also we discussed. Tell me one or two critical scenarios of banking application, any banking application. Like
Transfer money.
transfer money is one of the critical scenario. Okay, and let's say download statements is maybe a critical scenario, something like this. Now this is a scenario, critical business scenario. Okay, now for each of these scenario, we will again have a steps, a functional steps. Okay, like what are the steps? Like what is the functionality or what is the flow? Okay, so for transfer money, the steps or the flow will be something like this, right? So we generally launch the application. Okay, we generally launch the application, then we log into the bank application. Okay, and then mm, we actually navigate to our savings account or something like that. Navigate to savings account, and then we choose or select a beneficiary to whom we want to transfer the amount, and then enter amount, and let's say click transfer. Okay, enter amount and click transfer. Okay, and finally last step is logout of the application. Now each of these actions, okay, is or can be called as a transaction. Okay, in performance testing terminology, the important actions that we perform like these can be called as a transaction. Okay, so now launch is one transaction, login is one transaction, navigate to savings account is one transaction, choose a beneficiary is one transaction, enter amount and click transfer is one transaction, logout is one transaction. So how many transactions are there for this scenario? This is scenario name. This is critical business scenario. And in this scenario, if you want to reproduce the scenario, we need to execute these transactions. Okay, so 6 transactions for this scenario. Now, when you execute all of these transactions once, when you execute all of these transactions once, that will become one iteration. Okay, that will become one iteration. That will become one iteration. If you execute all of these transactions twice, that will become two iterations. If you execute all of these transactions 10 times, so 10 iterations. If you execute all of these transactions 100 times, 100 iterations. 1000 times, 1000 iterations, like that. So did you understand the difference between transaction and iteration? Because it's very, very important. Okay, so if you don't understand the difference, it will be difficult for you going forward in understanding or while executing or while doing workload modeling and all that stuff. So each of the action that we perform can be a transaction, and all the transactions in the scenario can be, if you execute those transactions once, that can be an iteration, one iteration. Execute 10 times, 10 iterations. Execute 100 times, 100 iterations. Okay. Now, the requirement from client can be something like this. Hey, can you test this transfer money scenario with 500 users? With 500 users, okay, with 500 users, uh, with target, with target of, with target of, let's say 2000 iterations. So this can be a kind of input that we get from client generally. So if you see 500 users, target of 2000 iterations. So this will be per hour. Okay. So generally, whenever you get any requirement, mostly we get it per hour. Okay. So this is 5000 users with 2000 iterations per hour. So what do you mean by 2000 iterations? That means each of these uh, transactions, like all of these transactions, if they get executed once, that is one iteration. So if they get executed 2000 times, that is 2000 iterations. That means overall, the requirement is something like in 1 hour load test, okay, in 1 hour load test, you should achieve 2000 iterations with 500 users. So in short, like how many iterations each user should achieve in 1 hour? How many iterations each user should achieve in 1 hour? Can you anyone tell? So
Four
if
iteration.
500 into 4 is 2000, right? So each user, if each user is achieving 4 iterations per hour, that means all 500 users together will achieve 2000 iterations per hour. Simple. This can be one kind of requirement. Okay, then there can be another requirement also, another kind of requirement also, like 500 users. Okay, um, 500 users to achieve, let's say 12,000 transactions per hour. Transactions per hour, you can call it as TPH. So what do you mean by this? So this is one transaction, two transaction, three transaction, four transaction, five transaction, six transactions. So all in all, the client is not giving input in terms of iteration, rather client is giving input in terms of transactions per hour. This is also possible. Okay, so you need not worry like how many how do I achieve per 1 hour. Okay, so we'll discuss that. But did you guys understand what kind of requirement we might get from client? So something like this. Any questions still here? Okay, so client can give you input at the application level also, like overall application client might give you 5000 users, and then the client might say that I don't know, like I have to see like how many for transfer money and how many for download statements. You have to go and check the SQL or Splunk or something like that to know like how many users are actually transferring money and how many users are actually downloading statements and all. Generally how do they find out is like whoever is navigating to transfer money page. So that, like that user, like that can be called, that can be counted as a page view. Okay, so there are some metrics like how they get that and all. We discussed last session also, right? So that's fine. So the generally the input will be something like this. Iterations, transactions. You should not get confused. Transaction is this: 3, 4, 5, 6. If you execute all these once, it will become one iteration like that. Okay. Now, uh, to understand the concept of workload modeling, uh, I can directly tell you the formula and all that stuff, but I want you to understand some basics of it, which is very important. So let's go ahead and try to understand in a better way. So here, um, now assume that we are doing workload modeling. Okay. So, okay, I'll tell you one more point. Now, here client gave one input 5,000 users, like 12,000 transactions per hour. Okay. Now, after running 1 hour of load test, if you go back and check the results, then you should achieve these transactions per hour, or you should achieve these iterations per hour. Okay. After running the load test, if you go back and verify the results, you should achieve this target. So how do you accurately achieve this target, or how do you achieve a target close to that number given by client? That's where workload modeling is coming into picture. Okay. So workload modeling is all about how do you evenly distribute or evenly pace the execution of the overall users, so that at the end of the test, if you go back and verify, you should be able to achieve the required target. Okay. So workload modeling is all about handling the users efficiently and in such a way that after 1 hour of load test, if you go back and check the results, okay, the user should achieve the target. Now let's go ahead and go to the slide. Now, just for our understanding purpose, uh, so this slide is all about workload modeling for login functionality. So in general, for any application, what are the general steps or actions or transactions we will have for login? So we launch application, that is launch transaction. We log into the application, that is login transaction. Then we log out of the transaction, that is logout transaction. Everyone understood? Okay. So these are the actions or transactions for login functionality. This is just for our assumption today. Okay. To understand the concept. So we are actually doing workload modeling for login functionality today. And then for login functionality, we will have these three steps: launch, login, logout. Okay, everyone agree? Now, in general, the scenario would look something like this. In general, the scenario would look something like this. So user would launch the application, and then there will be something called think time, and then login, and then again think time, and then logout. So, okay, these are transactions, like launch is one transaction, login is one transaction, logout is one transaction. But what about this? What about this think time? Think time. So in general, if you think from a real user perspective, uh, will you will you perform every action in a fraction of second on the UI? Generally, it's not possible, right? For example, you want to go ahead and purchase or buy television from some website. Now you go to the website and will you directly purchase it? No, right? First you go to the website and see what are the different options variants we have. We see different prices, we see different features of the television, and then we will decide. That means every user in real time will think for some time before performing the next action. Agree? Each one of us, any user, like real user, any application, the user will think for a few seconds or a second or couple of seconds or 3 seconds or 4 seconds before performing the next step. Okay. So you want to log into application. Okay, first you launch the application. Will you directly log in a fraction of second? No, right? First you will see where is the user ID text box or where is the password text box, so that you can go ahead and enter the username and password. That means you are taking some time, like it can be 2 seconds or 3 seconds, okay, or 4 seconds, like that. So that wait time is called think time here. Okay, the time taken by the user, okay, uh, to wait before performing the next action is called think time, or in short I can say think time is nothing but a wait time or time gap between two transactions. See here, this is one transaction, this is one transaction. In between whatever you have, the wait time is called think time. So this is one transaction, this is one transaction, again you have think time. See, everyone understood? Very, very important interview question also. What is think time? Think time is nothing but a wait time or time gap between two transactions. Okay. Any questions till here? Did you understand this concept? Why did I add think time in between? Why there is a think time in between? Because in real time also the same scenario happens. Every user will not go ahead and click every button or link in a fraction of second. Every user will think for a second or two before performing the next action. Okay. So any questions still here? Did you understand what is think time? Okay, are you sure? Okay.
Yes.
Now, now let's say we are going to, I mean, let's say the performance tester is will be creating a script for this. Okay, so let's assume performance tester is going to create a script for this. So and and assume also assume it would take 10 minutes for execution. So when I say 10 minutes for execution, this whole thing, launch, think time, login, think time, okay, logout, this entire sequence of steps will take 10 minutes, just for our assumption, only for today. Okay, so workload modeling for login functionality. Login functionality has 3 transactions as per the flow, and this is how the scenario would look like in real time. And assume that the script is ready. Script is going to be created by the performance tester for this flow, and also assume it would take 10 minutes for execution. Keep that in mind. Let's go to the next slide. Okay, so here in this slide, if you see, client gave target of 6 iterations per hour. Okay, this is again assumption or an example to understand in a better way. So client gave input as 6 login iterations per hour. Okay, and obviously we know that any load test would run for 1 hour. Okay, now there are two approaches. Okay, let's say currently I have mentioned two approaches here. Approach one, where there is a user one completing completing the iteration in 10 minutes. Why 10 minutes? Because I told you just now that for today, just assume that the login functionality would take 10 minutes for execution. Okay, so user one completing iteration one in the first 10 minutes and remaining 50 minutes idle. Why remaining 50 minutes? Because I told in load test would run for 1 hour. The target is also given for 1 hour, right? In that way, iteration one is completed. There is user two. Again, user two completed iteration in first 10 minutes and remaining 50 minutes idle. In this way, iteration 2 is also completed. There is user 3, user 4, user 5, user 6. Okay, user 3, user 4, user 5, user 6. Now, uh, in user 1, user 2, user 3, user 4, user 5, user 6, all 6 users completed one iteration each. Okay, in this way, 6 iterations completed. That is a target given per hour. Okay, we completed in 1 hour. First user completed first iteration in 10 minutes. Second user also completed one iteration 10 minutes. Like that, similarly, third, fourth, fifth, and sixth also. This is approach one. And then there is approach two, where there is a user and that user is actually completing all 6 iterations one by one. Iteration 1, iteration 2, iteration 3, iteration 4, iteration 5, iteration 6 in 6 iterations. This is going to be 6 iterations here in 60 minutes. Now you tell me which approach is better according to you in these two. This approach 1, approach 2, which approach is better according to you?
Second is more practical.
Okay, so considering these two, second option is better. The reason is in performance testing, okay, as per the standards, if a user is being idle for a longer duration, okay, or continuous time duration, then it is not considered to be a valid test. So what was happening in approach 1, every user, okay, in approach 1, every user, they were completing iteration 1 in first 10 minutes and remaining 50 minutes they are idle. Okay, so that's the reason this approach is not recommended. This approach is, sorry, this approach is not recommended. Uh, Second approach is better when you compare these two. Okay, now here also there is one more logic. What I'm what I'm saying is in this approach too, there is a user. Okay, however, there is one user. However, indirectly, there are 6 different users who logged in. Okay, can anyone tell how? There is a user, okay, which I'm saying there is user 1, and that user performed all 6 iterations. In that way, target is achieved. That's fine. But indirectly, 6 different people logged in. How?
We can use different credentials.
Correct. You can use different credentials. So you should always think from application perspective. See, take an example of Gmail. So we may see most of us or every one of us we have like 2 Gmail accounts. Okay, let's say one is for personal purpose and other one is for professional purpose. Now let's say I'm sitting in front of laptop and I first accessed my personal account and then I verified my emails, sent couple of emails, and then logged out. And immediately I signed in with my professional Gmail and then which I use for some business purpose. And then I verified some emails, I sent some emails, and then I logged out. So Gmail doesn't know that I am the only user sitting in front of the laptop and accessing 2 different accounts. Gmail doesn't know. Gmail only considers about the unique username and password. Okay, based on that unique username and password only, it is identifying the user. So Gmail doesn't know. Okay, so we should always think from application perspective. So here also in this example, application perspective, each time each iteration, the we actually passed a different username and password. In such way, it's like indirectly there are 6 different users who logged in this case as well. Okay, any questions? Because if I mean this concept is also a little important, and if everyone understood, well and good. If anyone didn't understand, no problem. You will definitely understand in couple of days or this week. Okay, so you'll get some idea like in few days from now. So hope you understood this concept. So 6 different people logged in indirectly here as well. Any questions? You should always think from application perspective. Whenever you are assigned to any project, always think from application perspective. Then only our testing approach will be correct.
So I have a question here.
Yeah.
So in the first scenario, we are giving the load in first 10 minutes. All the users are logging in, and the idle time is 50 minutes. In this scenario also, The user is are getting idle for same 50 minutes, but the application is getting some load in some interval. So what I
Uh,
understood from both.
yeah. So here the problem in the first approach is all users completed iteration in first 10 minutes itself. If this user would have completed in first 10 minutes, and let's say if these two users targeted for second 10 minutes, or if these two users targeted for third 10 minutes, something like that, that is
Mhm.
a little bit better, pacing. I mean, better way of executing than this approach. Okay, so
Mhm.
first 10 minutes itself, all users executed here. That doesn't make sense. So 50 minutes, all the users were idle doing nothing. Then what is the need of performance testing? So it doesn't make sense. So generally, as per the standard, the performance metrics is always taken based on the peak hour in sense where more number of users access the application. Okay, so considering that peak hour, we should also simulate that kind of behavior for our performance test. So now let's say there are 24 hours in a day, and let's say from 11 a.m. to 12 p.m. 1 hour, like 500 users were there actively working on that application. That is peak. Let's say remaining hours, like only 200 users were there or 300 users were there, something like that. So we are actually trying to simulate these 500 users, and those 500 users might be performing different tasks. Okay, so all those 500 users are active, but they might be performing some different task. That can be a realistic situation or scenario. This is not something realistic which performance testing doesn't accept. Okay, so we'll get to know.
But in case of spike, or you can tell spike test, you can that could be a right scenario, no? In
In
10
in
minutes, you are giving all the load, and rest of the
Correct,
time.
but in spike test, you are not allowing the user to be idle for longer duration. For example, if you are increasing the users, that means you are doing spike. Okay, what do you mean by spike? A spike can be a sudden increase or a sudden decrease in terms of users. Okay, so when you say sudden increase, let's say I added 50 users, and then I'm allowing those 50 users to run for 10 minutes, and then I'm suddenly dropping all those 50 users. That is a spike testing. So it's not like continuous idle time or something like that. It's like sudden spike increase in terms of users, run for some time, and then sudden drop. Again, sudden spike in terms of increase the users, and then run for some time, again suddenly drop the users, something like that. It's a different scenario altogether. But the basic scenario, what we generally discuss every time, is related to load test only. So in load test, we run for 1 hour, and we want to make sure that all the users are uh, executing at an even pace. Okay, it's not like one user is being idle for long duration, the other user is continuously executing. So these sort of situations shouldn't arise. Okay, so that's the reason workload modeling is actually implemented. So let's try to understand few more examples. Okay, so now let's say in this example, client gave 3 iterations per hour. In the previous example, client gave 6 iterations per hour. Now here, client is saying only 3 iterations per hour per user. Okay, in sense not per user. Basically, client didn't mention any user here. Just client mentioned 3 iterations per hour. That's it. So in approach one, there is a user one. Again, completing iteration one in first 10 minutes, iteration two in next 10 minutes, and then iteration three in next 10 minutes. In this way, 3 iterations completed in first 30 minutes, and then remaining 30 minutes idle. In the approach 2, user completing first iteration in first 10 minutes and then waiting for some time, and then again completing second iteration, waiting for some time, again completing third iteration, waiting for some time, something like this. So this is more realistic when compared to approach 1. Okay, now what is the time that what is the time amount of time that we are waiting here? That depends on the requirement. Okay, in this case it is 10 minutes because we overall we have 60 minutes per hour, and we just need to run 3 iterations per hour, and each iteration is we actually taking 10 minutes. So 10 minutes iteration, then wait for 10 minutes, then iteration 2, like that. Now whatever the time we are waiting here, the time period or the time gap or the wait time between two iterations is called pacing. Very, very, very important. So at an iteration level, if the user is waiting for some time, that is called pacing. At a transaction level, if the user is waiting for some time, that is called think time. Now, each iteration again will have the sequence of steps which I already mentioned, something like this. See, in iteration 1, this entire thing is getting executed, and then wait for some time, and iteration 2, again this entire thing is getting executed. Again iteration 3 also, this entire thing is getting executed. So think time, the interview question is, what is the difference between think time and pacing? Think time is nothing but wait time or time gap between two transactions. Pacing is nothing but wait time or time gap between two iterations. Okay, any questions? Okay, now the workload modeling, what we are discussing, is all about calculating pacing. Why we need to calculate pacing? Because I want my users to evenly pace the execution, okay, so that at the end of the test, if you go back and verify the results, the target will be achieved. Okay, if you remove pacing here, what will happen? If you, in this example, if you remove pacing, what will happen? If you remove pacing and you leave it like that, then what will happen? Instead of achieving 3 iterations, the user will achieve 6 iterations, which is not required. Okay, are you guys understanding? The target given itself is 3. Why do you want to achieve 6 directly? No, 6 we will achieve, but different, in a different type of test, not here, not the basic ones. Okay, so whatever the target is given, based on that we need to calculate pacing. Okay, pacing, the workload modeling is all about calculating pacing. Okay, pacing will be implemented to evenly pace the execution, okay, for per each user, so that at the end of the test, if you go back and verify the results, the target should be achieved. Let's try to understand one more example. Okay, let's try to take this example. Okay, different one. Now in this requirement, client gave this input, 6 iterations with 2 users. See, in the previous examples, client did not mention anything about users. Here, client explicitly mentioned about users. 6 iterations, 2 users. See, you can achieve 6 iterations in one user also. See, with one user also you can achieve 6 iterations, but client explicitly mentioned you have to achieve this with two users. So in this case, user 1 will achieve first iteration in first 10 minutes, pacing, again iteration 2, pacing, iteration 3, like that. Two users together, they are achieving 6. First user is achieving 3, second user is achieving 3. Together they are achieving 6. Now these two users who these two users running during the test, okay, concurrently, these are called concurrent users. These are called concurrent users. User 1 is also running something, user 2 also is running something. So user 1 and user 2 are called concurrent users. Okay, so there is another term called simultaneous users, which we'll discuss later. So here, so this 10 minutes is just for today's example, guys. Okay, now hope you understood why I have taken user 1 and user 2, because client explicitly mentioned you need to achieve the target with 2 users, and one user achieved 3 iterations, second user also achieved 3 iterations. Perfect. Okay, now so workload modeling will be done to calculate pacing. Pacing should be accurate so that we will achieve target. Since this example is only for 6 iterations, we were able to calculate pacing easily. But what if the iterations number is more like 500, 1000, 2000, 3000 like that, will you be able to calculate directly the pacing in your mind? So if I say 1000 users should achieve 7000 iterations, will you be able to achieve calculate or calculate pacing directly like this? No, you will not achieve, you will not you will not be able to calculate pacing directly unless you are a mastermind. Okay, so what then, how do we calculate? So if you want to calculate pacing for iterations like 5000, 500, 1000, 10,000, 20,000 like that, then we need to use a formula called Little's law. Okay, then we need to use a formula called Little's law. So Little's law actually is a formula. Little's law is a formula. Okay. Um, I mean, the name is derived. The name is like Little's law because the one who introduced this formula name was Little. Okay. So the formula is n equal to x multiplied by, okay, rt plus zt. Okay, just try to understand this formula. I'll tell you. So where n equal to number of users, x equal to TPS, transactions per second, or people call throughput also. Okay, let it be TPS for now. Okay, so TPS, how do you get it? How, see, who will give this n value to us? Are we calculating n value or someone is giving as input? Is anyone giving as
And
input? Client or application
Client or
team is
dev.
giving input, right? Okay, then what about this x value? X is nothing but TPS. TPS is nothing but transactions per second. So how are we getting these transactions per second is in, I'll tell you the simple shortcut. So whatever the TPH that you get it, whatever the TPH that you get, if you divide by 3600, that will become TPS. Why? Because 1 hour consists of 60 minutes and each minute consists of 60 seconds. So 60 into 60, 3600. So TPH, if you divide by 3600, you will get X value. Simple. Okay. So I can, if you want, I can make a note it here also for you. TPH divided by 3600. Okay. Then what is RT? RT is nothing but response time. What is ZT? ZT, or you can also call TT. Okay, this is nothing but think time. Okay, so these two, how do we get these two? So actually, when you develop a script, okay, when you develop a script and when you record a script, you need to put a transaction. Sorry, you need to put something called think time after every transaction. That's what I mentioned here also for you. Okay, so first launch will be there. Sorry, first transaction will be there, and then think time, and then transaction, and then think time. Right. So in our script also, I'll open the same demo script which we discussed uh, earlier. So if you see here, this is launch transaction. Okay, I'm whoever attended initial demo session, uh, they will have some idea. But otherwise, don't worry because we didn't start practicals. We will go through all these once again. So this is launch transaction here. Okay, if you remember in our initial demo session, then after that immediately we have something called think time. Okay, similarly what I have shown here, see, first one transaction, then think time. So here one transaction and then think time, and then second transaction login and then think time. See here, login and think time, something like that, and then log out. No need to put think time after last transaction. So you don't no need to add a think time after last transaction. Okay. So here also you can see practically think time. So think time here it is 4 seconds. Here it is 44 seconds. We can change it as per the standard. The think time can be anywhere between 5 to 10 seconds. So we can update it later. No problem. Okay, so when I run this script, okay, basically what is happening, uh, let me do one thing, let me go ahead and start the so- okay. So now when I run this, okay, when I run this, okay, I'm running this script. Okay, so I'm just replaying it, whatever we recorded, I'm just replaying it. Okay, one second. So on that day we changed something with respect to this script. I don't know what we changed. Anyone remember what did we change in the script on that day? Okay, no problem. Let me do one thing. Uh, okay, see, I just regenerated the script, so hopefully it should not throw any error. No. Okay, see. So on, I mean, our as per our previous example, I made some changes which I don't remember. That's fine. So here, uh, if you see, okay, if you see here, when you run the test, uh, here you get to see something called elapsed time. Okay, so this is nothing but basically this is nothing but script execution time. You can take it as script execution time. Okay, and then and then uh, whatever the, I mean, I didn't add think time here actually. One second, let me do one thing. I'll show you one example. Okay, let me give 4 seconds here and here also 4 seconds. Just be with me. Don't think too much now. I just want to tell you those parameters. Okay. So what I'm trying to do is I'm running the script. Okay. Now the script will run. Okay. The script ran successfully. Now this whatever time that I mentioned elapsed time. This I told you script execution time. SET. Okay. Script execution time. What is the script execution time? 9.282 seconds something. Now, in this script execution time, you have something called think time. What is that think time? If you go to the script, okay, you waited 4 seconds here and 4 seconds here, that is 8 seconds. So, out of this 9.282 seconds, 8 seconds is nothing but think time. And remaining time, whatever you have, that is called response time. That means whatever you get it after adding all this, that will be okay, that will be called as response time. Okay, so overall we call it as script execution time. From that, if you deduct think time, you get response time. Or the other way, if you add think time plus response time, you get script execution time. Okay, so this can be actually uh, modified to something like this. Can I write something like this? No. So instead of RT plus ZT, I can simply write SCT. So SCT is nothing but script execution time, which is combination or addition of a response time plus think time both. Okay, so that I have shown here. So this is the overall script execution time, and this is, if you add all of this is response time. If you subtract that from script execution time, you will get think time. Anything, either way you can do it. That's fine. Now, for performance testing world, okay, it is just an addition. I mean, you just need to calculate pacing. The formula for performance testing, guys, would be something like this. Okay, now this this is your actual formula. Now, when you have three values, can't we find the fourth value by doing some algebraic calculation in this expression, like bringing the value from that side to this side and then something like that. Okay, so the formula, okay, if you go to any interview, you can tell the formula as this one. Okay, and then you can tell that it can be further enhanced to something like this so that you can calculate pacing easily. Okay, now, um, okay, so I mean, no, what you can do is like actually, um, you can bring the left hand side value to the right hand side, and you can say, sorry, right hand side value to the left hand side, like you can write n by x and all that stuff. But I don't want you to confuse you because it will be a little bit confusing if you further enhance it and calculate it here. Uh, to to understand it easily, I just added this table here. Okay, I just added this table here. So we'll try to understand or calculate some value based out of this table. So just for today's example. Now, generally, let's say this is one application, e-commerce application. It has four different scenarios. It has four important critical scenarios. One is purchase order, one is cancel order, one is checking transaction history, fourth one is window shopping. Okay, everyone agree? Purchase order, cancel order, checking transaction history, and window shopping. Okay. Now, let's say client gave this input to us. Okay. For purchase order, client said the transactions per hour is 12,000 and the user's n value is 700. And coming to script execute, see n value we have it here. Okay, x value we'll calculate, but client gave TPH transactions per hour 12,000 for purchase order. Script execution time, where we will get script execution time? We have to develop the script. We have to run the script. Okay, in Vuegen, something like this, and then when you get the elapsed time, you can take it as script execution time. But currently, we don't have that script ready, isn't it? Currently, we don't have that script ready. So that's the reason I just added some dummy number here like 50. Okay, so that we can calculate. Later on, when we develop scripts, we will get it from Vuegen. For time being, I just added here as a dummy value. Now, these are the input given by client, and this is the value which I got it after developing the script and running the script in my local Vuegen. Now, I need to calculate pacing. I have these three values. Okay, I have this value but indirectly. X value I have but indirectly. Okay, let's see. So you just need to keep it simple. Just calculate these three columns. That's it. So first thing is what you need to do is this X value, which we are calling it as TPS, transactions per second. X value we are calling it as transactions per second. Just divide uh, that divide this TPH value by 3600. So I'll open the calculator. So here, what is TPH for purchase order? What is TPH for purchase order? 12,000, correct? 12,000 divided by 3,600 because the input given to us is transactions per hour. I'm just trying to convert it into transactions per second. Okay, like using the shortcut. So 3.3.333, something like that. Okay, so you got some value here like 3.333. That's it. So we have these three now. When you have these three, can't you find this one? You can. So the next simple step that you can do is simple, bring that uh, you know x value to the other side. So it becomes n by x. Okay, what is n for purchase order? What is n? I'll again open the calculator. What is n? N is
700.
700 divided by what is x? 3.3.3 something something. So you're getting 210. So n by x is nothing but 210. And then pacing is nothing but n by x, this column minus SET, this column. N by x minus SET. Okay. So what is 210 minus 50? That is 160. So 160 is your pacing value. Okay, actually in our tool, so where should we give this 160 so that the users will actually wait for 160 seconds? So what happens here when I got 160 as pacing? So now when I run this script for 1 hour, okay, with 700 users, each user after every iteration the user will wait for 160 seconds and then go to the next iteration. In that way, after 1 hour, if you go back and check, you will achieve the target. Okay, but where to give or enter this 160? So basically, it should be in the runtime settings. I'll tell you that later, but for time being, I'll show you here at a very high level. So in the runtime settings, in pacing, you need to give that value here, 160. You can select that second value and you can give 160. There is third value also. I'll tell you that later. Not required now. Okay, but it's again, it is also from this table only. Okay, uh, we just need to take this as third value. We can discuss that later. Not required. Okay, so I just want you to understand some terms and terminologies of workload modeling, so that we will be using those terms in our entire course. So later on when we implement practically, I'll tell you like what is this second option, what is this third option, can we use second or third, which one to use, all these things we'll see. So but whatever the value we calculated here, this 160 should actually go here in the second option. Okay, so what is the third option? Actually, third option should be here, this one, but I'll tell you when to use that. What is the, can we use either of that and all those things later. So similarly, you can calculate it for the second one also. Okay, second, third, fourth also. See, later on in our upcoming sessions, once we are done with scripting, when we actually execute the load test, practical load test for 1 hour. So actually in our course, we will run a load test for 1 hour. Okay. So when we do that, we will try to understand, we'll calculate pacing at that time, and then we will discuss, we'll run the load test and then we'll verify our results, whether we achieve the target or not. Sometimes what will happen, client will not give users at this level. Okay, client will give users at the application level like this, overall application level like this, 2000. So what do you mean by this? It means client is saying that I don't know like how many are doing purchase order, how many are doing cancel order and all, but overall for all of these together, the users are 2000. That's what client mentioned. And now you can calculate how much how many users to be assigned to each scenario here. You have to calculate. I'll tell you that later, not required, that not that urgent. Okay, so don't worry about it. So here these are the 4 different scenarios. We can also call it as business process. Okay, don't get confused. A scenario, a critical business scenario or business process, both are same. Okay, so there is something pending from this topic which we'll be discussing directly in our practical sessions, because you need to understand the core concepts of think time and all that stuff in detail. So that will come only with scripting practice. So once we are done with scripting practice, when we switch to execution, I'll tell you all those things practically. Okay, so today why did we discuss this? Then you can ask me, sir, when we are actually when we are supposed to implement this later on after scripting, then why did we discuss today? Because here when I record the script, we will record different scripts, various scripts, right? So when we record scripts, you will see these terms, think time, somewhere in the middle. And I'll tell you like, okay, I'll run this for two times or 2 iterations. Then you should not get confused, like what is iteration, what is transaction, all that stuff. So I repeat, this is one iteration. Sorry, this is one transaction. This is one transaction. Like that, 6 transactions. When you execute all these transactions once, it is one iteration. Okay, and then based on the target given to us, in order to achieve the target accurately or close to that number, we need to use little slow for pacing. Without pacing, you will not be able to achieve the target accurately. Okay, it's straightforward. So if client is giving you this target, and after 1 hour of load test, if you go back and check, you are not achieving this, or let's say target given by client is 12,000 transactions per hour, let's say you achieved only 8,500. What could be the issue? Can anyone tell what could be the issue? If client is giving you target of 12,000 transactions per hour and you are achieving only 8,500 after 1 hour, what could be the issue?
Pacing.
Incorrect pacing. That means you calculated pacing incorrectly. You have to rectify that. You have to work on it. Or if you get very high response times during your load test execution, that will directly impact the target. For example, now when I ran the script now here, okay, for one iteration, I'm getting like 9 seconds. And let's say login is taking 1 second, log off is taking some 0.1 second, something like that. Now, when I'm running the load test, let's say for some XYZ reason, login is taking 7 seconds instead of 1 second, let's say. Then because I calculated pacing, assuming that it would be something like this, and the script execution time would be something like this. But when I'm actually running the load test, these times increased, which automatically had impact here, and this will automatically have impact on the overall target that we need to achieve. So all in all, if the target is not achieved, either it could be incorrect pacing or there could be very high response times. If it is incorrect pacing, you need to fix it. Okay. If it is very high response times, developer should fix the performance issue, and then you need to run the test again, which should eventually, after which eventually you should achieve the target. Okay. So as simple as that. Any questions? And also, I will tell you some shortcuts on how to calculate pacing later on as well. Okay. So I mean, it is also based on little slow only, those shortcuts, but then it will be easy for you to remember and calculate and all that stuff. Any questions? So from tomorrow, we are going to, we will be doing some installation. Okay. I'm not sure whether did you guys receive any, like, any email with all the initial documents and, or anything? No? Yes, no? Anyone?
No, no.
Okay,
No,
okay.
not yet.
So I will check with the team. Probably you should get in a day or two. So whenever you get it, you should be downloading all the documents and whatever the softwares or applications or whatever it is, and then we are going to start practical sessions from tomorrow. So by tomorrow, if you are not getting the email which I mentioned, so tomorrow what I'm going to do, I'm one more practical session of how do you record the entire flow, but I'll explain a little bit in detail. Okay, and I'll tell you some tips and or some features, some recording features, and what is this recording report, what should we verify here. Okay, and also I'll tell you like some shortcuts here, and okay, it's like an understanding the tool. So I'm sure by day after tomorrow, I think everyone should get that email at least in worst case. And then we will make sure each one of you will also start practicing. Okay. So after tomorrow's session, we will discuss how to record how to record using this tool. What if you are unable to record? What is the alternative? And then what are these runtime settings? What are these runtime settings? And then we'll start with C language basics, and then we'll proceed with some LoadRunner concepts for the LoadRunner concepts. Okay. So if you have any further questions, do reach out to me on WhatsApp. I'll be able to assist you. I'll call you back.